All right, today we're going to be doing 5.4 logarithms part 2. We're going to start off with an example. Solve each equation. And we're going to round the answer to the nearest 10,000th. Now, when I say 10,000th, know that that is 4 decimal places. I'm going to go ahead and I'm going to write the steps on the right side. Now, if you notice, your variable's in the exponent. So you need to isolate the base with the exponent. So I need to isolate the base with the exponent. Luckily, in this case, there's nothing in front of it or behind it, so it's already isolated. Now, I'm going to take the logarithm or the natural log of both sides, because whatever you do to one side, you're going to do to the other. So right here, I'm going to take the log of 25, and then I'm going to take the log of 10 raised to the x minus 1. Now, recall the properties of logarithm. Now, in the properties of logarithm, you can move this exponent to the front. So now we're going to use the property of logarithm to move the exponent to the front. So this is going to go out to the front. Now make sure that that stays together. So it's going to be a parenthesis x minus 1, logarithm of 10, and then we have the logarithmic of 25. Now we have to just solve for the variable. So we're going to solve for the variable. Now this says x minus 1 times the logarithm of 10. I'm going to go ahead and divide both sides by a log 10. So now on the left side, when I type this in my calculator, I have a log 25, so log 25 divided by, and I close my parenthesis to make sure that I'm done with the logarithm, log of 10, logarithmic of 10. I'm going to leave that number in my calculator because I don't want to round yet. So let's write it's all down, 1.397940009. The log 10s cancel, and now I'm left with x minus 1. Keep in mind, you are still solving for the variable. So I'm going to go ahead and I'm going to add 1 to both sides. And now 1 plus this number right here is going to be a 2.397940009 equals x. And you're going to go to 4 decimal places. So we're going to cut it off at the 9. The 4 does not make that round up. So I'm going to be left with 2.3979 is equal to x. Now to check your answer, I have a 25 equals 10. Now the x is, I'm going to plug in a 2.3979 minus 1. So let me plug that in. So I have 10 raised to the 2.3979 minus 1. And that equals 24.99769, which this is basically going to be a 25. It is 24.997699702, which is really, really close to 25. go ahead and solve another one. Remember, you have to isolate the base with the exponent. Now, you see how this says plus 0.125? I need to put that to the other side. So I'm going to go ahead and subtract the 1.5. So now I'm left with 10 to the x power equals 17 minus 1.5 is 15.5. Next, I'm going to take the logarithm or natural log of both sides. I'm going to do natural log this time just to show you'll still get the same answer. Right here, the same thing. So I'm going to take natural log on the left side, natural log on the right side. Using the properties of logarithm, this exponent can go out to the front. So that is going to be an x natural log of 10 equals natural log of 15.5. Then I'm going to go ahead and divide both sides by natural log of 10 because you are solving for x. So I have natural log of 15.5. I'm going to close my parenthesis, divide that by the log of 10. So x is going to equal to, now I'm going to go to 4 decimal places, so I'm going to stop right there. 1.1903. On this one, there's your exponent, so that's what you're trying to isolate. You need to isolate the e raised to the t power. Now that says times 4.15. So I'm going to go ahead and I'm going to divide both sides by 4.15. So now I have e to the t power equals 34 divided by 4.15. Keep that number in the calculator. As of right now, I have a 8.192771084. I'm going to keep the number in the calculator. Now, you have to remember the opposite of E is ln. So the opposite of E is natural log. So you're going to take the natural log of both sides. So I'm going to take the natural log on the left side, and I'm going to take the natural log on the right side. So on the left side, I have natural log of e to the t. On the right side, I have natural log of 8.192771084. Natural log and e, they cancel each other out. And then you're just left with the exponent, which is t. Now, I left that number in my calculator. So what I'm going to do is I'm going to hit natural log. And then I'm going to pull that answer. And the way I pull that answer, or I could type in all the numbers if I wanted to, I'm going to go ahead and I'm going to hit second, the negative, because that says answer. Now what that does is it pulls the answer from above down. And I get 2.103. Now that 2 is going to round up because of that 5. You're going to 4 decimal places. All right, let's go ahead and let's go on to example D. Now on this one, we need to isolate the logarithm. Well, in this case, it is. There's nothing in front of it or behind it. Now, keep in mind that this is base 10. You just don't see it. I'm going to change this to exponential form. So we're going to rewrite in exponential form. So this is going to be 10 squared equals 3x minus 2. Well, now you just got to go ahead and solve it. 10 squared is going to be 100. I'm going to add 2 to both sides, so 102 equals 3x. Divide by 3 to both sides, so 34 equals x. Now you can go ahead and check your answer. So I'm going to have a logarithm, and then I have 3 times the x value I found to be 34 minus 2. Now the answer should be 2, and look, comes out to be a 2. Keep in mind, you have to isolate the logarithm. So this times 2, I need to move it to the other side. So the opposite of times 2 is divide by 2. So now I'm left with log x plus 1 equals 7 over 2. Now there's a base 10 here. You just don't see it. I'm going to rewrite it. So this is going to be 10 raised to 7 over 2 power, which is 7 over 2. That's actually 3.5 equals x plus 1. So in my calculator, I'm going to type in, because then I need to subtract 1 here. I have a 10 raised to 3.5, get out of my exponent, and I'm going to hit minus 1. And remember, you're going to 4 decimal places, so that it's going to end at 0.277, and that's going to be a 7. On this one, the natural log is isolated. Now, the opposite of natural log is e. So I'm going to take e of both sides. So basically what it is, it's going to be e raised to the natural log of 2x minus 3, and that is going to equal e to the 5th power. E and natural log cancel, and I'm left with a 2x minus 3 equals e to the 5th power. So now I'm going to go ahead and I'm going to add 3 to both sides. So now 2x is going to equal e to the 5th plus 3. Then I'm going to divide both sides by 2. Now I'm going to use my calculator. First, I need to do the numerator. So the numerator is e to the 5th power plus 3. Now divided by 2. So leave that answer. So it's pulling the answer from above, divided by 2. And I get 75.7066, because the 7 is going to make that 5 round up. We're going to get into some word problems now using exponentials. How long does it take for $600 to grow to $1,200? So basically, it's to double. At 3% annual percentage rate when compounded continuously. Now, the general equation is APERT. A is equal to the principal E, which is a constant number, raised to the RT. So P is going to stand for the principal. What's your initial amount? R is going to stand for your rate, and T is going to stand for your time. So right here it says how long. So right there, it's asking you for what is the T value. So T, I don't know. Does it take for $600 to grow to $1,200. So that's going to be your principal amount. That's your initial amount. That is my initial amount. So the P is going to be a 600 to grow to 1,200. So that's what you want to end with. Your A. So your A is going to be 1,200 because that's what you want to end with. And then right here you have 3%. That's going to be your rate. Your rate is going to be 3%. Now you can't plug in 3%. We need to change that to a decimal. So you either divide it by 100 or move the decimal 2 places to the left, which is 0.03. So here's my equation. The A is going to be 1,200. The P is going to be a 600. E is a constant number. R is going to be the 0.03, and then T is going to be the variable. You are solving for the variable. The variable happens to be the exponent. So I need to get this E all by itself. Now, the way to do that is to cancel out that 600. So I'm going to go and I'm going to divide by 600 to both sides. So here I get a 2 equals E to the 0.03t. And then the opposite of E is ln. So I'm now going to take the ln of both sides. So here's going to be ln of 2, ln E 0.03t. So on the left side, I'm left with ln of 2. On the right side, the ln and the E cancel, and I'm left with 0.03t. Now you're solving for t, so go ahead and divide both sides by 0.03. In my calculator, I have natural log of 2, close my parenthesis, divided by 0.03. So I get a 23.10. Now that's going to be a 49 equals t. So it will take about 23 years for the money to double. Let's do one more word problem. The Richter magnitude of an earthquake is R equals 0.67 logarithm of 0.37 capital E plus 1.46, where the capital E is the energy in kilowatts per hour. Released by the earthquake. A, what is the magnitude of an earthquake that releases 9 billion kilowatt hours of energy, and I want you to round to the nearest tenth. Now, tenth is 1 decimal place. Now we have this equation right here. R equals 0.67 log 0.37 E 1.46. And then it says right here that it releases the 9 billion kilowatt per hour. I'm going to plug that into the E. So R is going to be equal to 0.67 logarithm of 0.37 times 9,000,000,000 plus 1.46. 0.67 logarithm 0.37 times 9, and then I have 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Close my parenthesis, plus 1.46. And I get 7.84. Now remember, I said round to the nearest tenth, which is 1 decimal place. So I'm going to cut it off right there. So it's 7.8. So this is going to be a magnitude of 7.8. So that one was pretty straightforward. Last one. How much energy would an earthquake release to be a 6.9? So now I'm giving you what the answer should be. So I'm giving you the R value here. On the Richter scale, now this time we're going to round to the nearest whole number. So let's go ahead and let's write our equation. R is equal to 0.67 log 0.37 E plus 1.46. Now 6.9 here is going to be the R value. So I have 6.9 equals 0.67 log 0.37 capital E plus 1.46. Now you are solving for the E. Now we have to get rid of this 0.67 and the 1.46. I'm going to first get rid of the add and subtract because remember you're doing order of operations, but you're going reverse. Minus 1.46 minus 1.46. So I have 6.9 minus 1.46. I have 5.44 equals 0.67 logarithm 0.37 to the, times E. You're still trying to get the E by itself. You can't cancel the logarithm out. You have to get rid of this times 0.67. So I'm going to divide both sides by 0.67. $5.44, I'm just going to hit divide 0.67, so it pulls the answer down. I'm going to leave that decimal in there. Do not round. 8.119402985 equals the logarithm of 0.37 E. Now, I'm going to go ahead and I can cancel out the logarithm. I'm going to rewrite this in exponential form. There is a base 10 here. You just don't see it. Start off with the base. So that's going to be 10 raised to that exponent is going to equal this piece. So it's 10 raised to this exponent is going to equal 0.37 E. Before I type this in the calculator, keep in mind you're still solving for E. So divide both sides by 0.37. So I'm going to type this in. Now I already have that number in the calculator. So I'm going to hit 10 raised to, I want to pull the answer down, or you could type it all out. To pull the answer down, I'm going to hit second and then the negative key, so that pulls the answer down. So it's just like me typing all those numbers in. I'm going to hit equal. Now I'm going to divide that by 0.37. Now remember, you want to round to the nearest whole number. So that 6 is going to make that round up to a 4. That 6 is going to make that round up to a 4. So I'm left with 355,796,164. Now, what are the units? It's going to be kilowatt hours. I'm going to put a comma after every third. And that concludes our notes.